Okay, my good people, get you some good paper and a good journal, some good room, pencil, erasers. We about to do a set of practice problems here to get us ready for quiz number 2. Let's go. Okay, welcome to I guess our first support video for getting ready in anticipation for our second quiz. And welcome. So in this particular video, we're just really I'm not going to be going through like a lot of theory, but like some tricks, some traps that you might have, things you want to look out for. Covering the things that you will definitely encounter on quiz number 2. So let's get right to it. Why don't we? So let's familiarize ourselves again with the number system. So you will definitely see something on this quiz around the number system, right? You might have your infograph next to you. I like this one, right? Because you see natural and then whole and then integers, rational, irrational numbers are over here, right here. And then all of these are encompassed by this idea that they are real numbers, okay? And also, right, familiarize yourself with the letters we use to symbolize when we're talking about rational, whole, integer, all of those. And then the symbols of union versus intersection. So there's a few things here, right? So you might see something on the quiz that says something like this. And we're going to use this information to kind of build out a few things that we can practice. Now, because I'm also throwing this in Edpuzzle, I'm also throwing this on YouTube, but in the Edpuzzle, there'll be certain places for you to stop and I'll ask you certain questions so you can kind of quiz yourself against the video to see how well you're doing. And if you're doing well, awesome. And if you're not, then it gives you places that you want to shore up, you want to firm up, maybe check out some problems with your classmates there, or hit me up for a lab, okay? So we'll do a few examples here. So how about this? Set Z. I want the set Z to intersect with W. In this case, I'm asking about, oh, I missed that. Haha. Sorry. And friends, you might have caught that. That was an error on my part. We do not use I for integers. We use I for irrational. And I also, sometimes I really like to capture my mistakes because, math is just a learning process. We all make mistakes. So I'm going to go ahead and make sure I highlight that we use the capital I for irrational and the capital Z for integers. So in this problem, right, I want to look at the intersection, what they have the same of set of integers and set of whole numbers. Using our infograph here, the intersection of integers, whole numbers. What's your answer? Well, your answer could be all the whole numbers. Because we know, right? We know that you can't have negative whole numbers. That doesn't work, right? So if you wrote something like this, or I would accept all whole numbers, something like that. And I've also seen a few of you friends do something like this, where you start to write out the whole numbers like 0, 1, 2, 3, and then you give me like a dot here. This is off, like all of these are fine. All of these answers are totally fine, okay? Let's try another one. Now I want set Q and the union of set Q with set I. In other words, I'm looking at the OR, rational numbers and irrational numbers. Maybe the infograph will help. What are you thinking? What's your answer? If you put some form or version of all rational and irrational, I'll accept that. And if you took it a step further and said, oh, well, if we're talking about the union of rational and irrational, well, that makes him real. That means everything is real. All real numbers. So if you put something like that, or all real numbers, or capital R, I would accept that as well. I'll go ahead and put the capital R here as we keep going. Excuse me, let's try one more. Now I want set R to intersect with set I. In other words, what do they have in that's the same? Rational numbers and irrational numbers. What's your answer? If you were leaning, friends, to empty set, right? Because they don't have anything in common. They're literally categorized to be apart, right? Or you use that symbol there. That's what I'm looking for. So what I'm trying to get you to understand in this process here is that you can have, right, when you want to write a lot of numbers, when we're talking like all the elements, when you want to write a lot of elements, we use letters to symbolize all of that. And you can see there's a problem where sometimes you have empty set is your answer. If you put 0 here, if you put 0 for your answer, that's not an answer, right? 0 is an element. So, no. Okay, we're going to move on from this, but there's a couple things I want you to remember. So let's just say, let's look at this set of an example. And I'm writing this out because I want you to make sure you zero in on some things. I can go ahead and erase this because I just want to remind you of some things. On the quiz or any kind of assessment or homework problem that I give you, we were talking about, sets with tons and infinite amounts of elements. Well, sometimes I can give you sets with a finite amount of elements. We talked about that. But make sure you understand what you're looking at here. If I asked you to name me whole numbers, all the whole numbers you see here, how many answers do you see? All the whole numbers. Well, if you're looking at this correctly, you should see 2. Right? Square root of 49 is 7. That's a whole number. 14 divided by 2 is 7. That's a whole number. Even though I've presented it like this, don't fall for the okie doke. Don't. Right? Pi, irrational. Which one would be rational? R. Which one would be, Q. Which ones would be rational? Right? I want you to think about this. That's rational. And if we're looking at that, 0 falls into the whole number category, so that's rational. 7, like we already talked about this, rational. Number -5, integer, rational, right? Pay attention that you don't fall for the traps that I might put out there for y'all, all right? Let's move on. I was using my trusty handy dandy Microsoft Xbox controller. Shout out to you gamers out there. Let's take a look at some word problems, shall we? Like we shall. So let's just dive right into it. Actually, yeah, let's start with these. So it says, we'll start with an age problem. So if you've been curious about how to do some of these age problems, I got you right here, family. Okay, let me get my stuff out of my way. So let's go. Martine is 3 times as old as his son Jackson. In 12 years, Martine's age will be 1 year less than twice his son's age. How old is each person? Okay, we know we have to come up with variables. So I'm going to use M for Martine and J for Jackson. We know at the beginning it says Martine is 3 times as old as his son. Let's think about translating that, you all. M, 3 times, 3J. Now let's take this next piece, because this is uber important. In 12 years from now, Martine, right? Let's just deal with that. Okay, 12 years from now, we're talking about this whole scenario here. Who is affected by the 12-year difference? Is it Martin? Is it Jackson? Is it both? Well, that makes sense. It's both, because if we were talking about 12 years from now, I have to be included in that, right? Time doesn't stand still for me. So we have to make sure that we include 12 years in 12 years. That's further. So that's plus. 12 years ago would mean minus, right? So we got to make sure, one, that both of them are accounted for in 12 years. Now let's do some work. Martin's age will be 1 year less than twice his son's age. So this is the son's age. So this is 1 year less than twice the age. See how you have to make sure that you capture Jackson's age like this. This, if your answer was this, remember, that's not telling the story. That's something totally different. All right, so let's do some math here. M plus 12, you got your 2J. Do not forget to distribute, my good people. M plus 12, you got your 2J plus 23. Now, you may diverge from me in terms of which ones you move first, but we all should end up in the same place. So you keep working, because I want you to meet me at the answer. Now, look, I got two different variables here. I don't want this. Haha. So I'm going to go back and use my first equation. So I'm going to substitute in this M with a 3J. Hopefully, friends, you are going in front of me. Okay. And you got a J here, plus 12, 23. Oop, let me move my paper real quick. Sorry, y'all. We're going to subtract 12 on both sides. And we get a J equals 11. So that means Jackson is 11 years old. And if Martin is 3 times his age, 33. Okay, let's keep it moving. Let's try this one here. Here we go. Blanca, now we're going to go to a coin question. And I'm purposefully saying, like, making sure I tell you which kind of questions we're going over in case you want to skip forward because you feel comfortable with those types of questions. That's fine too. All right. So we're going to go to a coin word problem question. I like to call them coin questions. Here we go. Blanca has 36 coins totaling $3. And the coins are all nickels and quarters. Oh, okay. How many of each coin does she have? Well, you know, we always start with our variables. So we got nickels. We got quarters. First things first, let's deal with the number of them, the quantity of the coin. What's that first equation? I think you got it, friends. M plus Q is 36. And now we need to deal with the monetary value of this. And this is where some of us get hung up. What's that equation? I'm going to give you a chance to write it down before I do. This is what we are going for. Make sure. Now, some of you end up starting here, right? Some of you might have started, 5. But does that 5 describe the value of a nickel? No. And some of you might have did this. I did 0.5. But is that the value of a nickel? Be careful, right? 0.05 is what we want. That's 25 cents for the $3. Now, the big question is, you know we don't do decimals. So what is the number I'm going to multiply everything by in order to get rid of my decimals? 10, 100, or 1,000? Hopefully you came up with 100, right? Because we want to make sure we get rid of the decimals here and everywhere. So let's go. So multiplying that by 100 gives me a 5n plus a 25q equals 300. Let's do a little substitution work over here. I'm going to substitute an n. So I'm going to make this equation n equals. If you made it a q equals, again, that's fine, but we should end up in the same place in terms of an answer. So I'm going to set this, as an n equals. And that means I have to subtract. I'm going to do it so you can see it. I don't want to just talk through it. So by moving the q to the other side, I get 36 minus q. And that's what I'm going to put here. Sorry. Okay. So 5 times 36 minus q. Remember, I'm going to cut this off and I'm just going to write it over here so we can have it. In case you look back at this, you're like, well, where did he get this from? I got you, I promise. Plus 25q equals 300. 180 minus 5q plus 25q equals 100. Keep combining them terms, y'all. Keep combining them terms. Let's go, friends. 180 plus 20q equals 300. Don't solve for that q yet. We got to keep rid of things. We got to move things out of the way. You got to move things out of the way. So let's move them. You got this minus 180. Boom. Over here, equal sign says whatever you do to one side, you got to do to the other. Don't play with me, y'all. Don't hurt me. 200q with the 120. You got it. Divide that 20 out. Chick, cut, boom. Q is 6. So that means we got 6 quarters. That means 30 nickels. Ow. Slide over. Okay. How you feeling? How you feeling? You feeling strong? You feeling good? Okay. I promise you, I got 2 more questions and I'm done. Just 2. Oh, no. We got 3 more. 3 more. I lied. Ain't no 2. We got 3. Let's go geo for you on this. Let's get this out of the view. Let's go geometric for a second. In this kind of problem, I'm going to want you to find the angles of each of these. Notice my question. I want you to find the angles of the 3 of these, right? So this is a geometry, if you will, geometry word problem. So if you feel good about the triangle ones, it's a triangle geometry problem that we're doing. And I want you to solve for all 3 angles. What are they? Well, you should know why not you, we all should remember that when you add up the degrees in any kind of triangle, that adds up to 180. So if I add up these 3 and set it equal to 180, I might be cooking with some grease here. So that angle plus my second angle here, minus my third, equals 180. Okay, adding all these up, we have a 5x minus 20 equals 180. That's right, set that 20 over there. We don't need it on this side. We got stuff to do, people. Divide everything by 5. X equals 40. Do not stop here and say, oh my God, I'm good, I'm done, I did it. No. Remember, right, the question is always probably going to be from me, what are these angles? So if we apply back in this 40, that makes this angle a degree of 10. That makes this a degree of 80. And that makes this a degree of 90. All right, we still feeling strong, friends? 2 more and we out. So this is the one I usually get the most questions on. The consecutive number word problems, the consecutive ones. So let's run it, fam. 5 times the smallest of 3 consecutive odd integers is 7 more than twice the largest. What are these numbers? First things first, we're talking about 3 consecutive odd integers. So if my first, being the smallest here, is x, what's the next consecutive odd? Now, I'm making my x the smallest. You might make your x the middle value, which is totally fine. Some of you are into that. But for this video, I'm always going to make x my smallest. So my second next consecutive meaning next, odd integer is 2 more than my smallest. That makes sense, right? 3, 5, 7, 9. 3 to get to 5 is 2 more. To get to 7 is 2 more, right? So to get to the next one is 4 more. Now let's see if we can put this back into the problem. 5 times the smallest, okay, that's a 5x, is 7 more than twice the largest. 7 more, I'm gonna plus 7 over here, twice the largest. Bam! Okay, people, what do we do first? You better had said distributed property. Now I'm gonna go a little bit slower so you can beat me to that answer and see if you can get there before I do. And if you don't, we'll get there on time. And if you get there late, at least you got there. All right. So let's move this 2x over here. I got my 3a. I got my 15. I'm going to divide by that 3 here. Bam. And then x equals 5. You are not finished though. No. Because you can't be like, oh my God, I solved my x. I'm good. No. Go back and answer the question. What are these numbers? These answers would be 5, then 7, then 9. Ah, ha, 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 ha. Okay, let's practice this one more time. We got one more. We got room for one more. We got one more question for you. Just one more question. All right, let me stop. Check it out. One more consecutive problem for you, and then we're good. 3 times the second of 3 consecutive even integers is 12 less than twice the sum of the first and third integers. What are these numbers? Do not let all of this lingo here confuse you. You got this. So we know we name our smallest integer, even integer in this case, x. And just like with odd numbers, same thing happens with even. 2, 4, 6, 8. To get from 2 to 4, you got to add 2. And to get to that 8, you got to add 4. Or get to the 6, you got to add 4. Right? Now, be careful because the problems, I might give you a problem that says consecutive integers versus consecutive odd or even integers. It's a different setup when it's just consecutive integers. All right. So now let's see if we can play some of this stuff in here like chunk. It says 3 times the second. Okay, 3 times the second of these 3 consecutive even integers, we got that already, is 12 less than, there's that less than again, 12 less than twice the sum of the first and third. All right, I'm gonna need a little more room here because I know that minus 12 gonna sneak in here, but twice the sum. Sum is addition, so I'm gonna add those together. All right, that first one plus the second. And make sure I got that minus 12 sitting on now. Now let's do some math. Distributed property. 3x plus 6 gives me a 2x plus 2x plus an 8 minus 12. All right. Let's do some combining of terms, people. 4x gives me a minus 4. Remember, you might diverge from what I'm about to do, but we should end up in the same place. Minus 3x. Minus 3x. 6 equals x minus 4 plus 4. If x is 10, then that means my answer is 10, 12, and 14. All right. Oh. There you have it. Okay, friends. We've tried it. You've gone through it with me. If you feel good about all this, that's great. If there are things that came up for you, nuanced things that came up for you, right? That is the place, that is the area you want to go over. That's the part you want to practice, because you might not need to practice the whole thing. You just might need to remember certain things, okay? And if you're still feeling uneasy, let's set a lab. Let's set some time to talk. Let's do this. All right. Other than that, thank you so much. And I look forward to having a great one with you. Be well.